Hi, and welcome to training on how to use the Unstable Slope Management Program to evaluate unstable soil and rock slopes. This Unstable Slope Management Program, or USMP, has been developed for federal land management agencies as part of a transportation asset management program focusing on geotechnical assets. Unstable slopes are natural and built earthen slopes that cannot stand in their current configuration. When these slopes are adjacent to roadways and then fail, soil or rock material falls onto the road, or when the earth below is unstable, the road cracks and drops. Both scenarios create hazardous conditions and increase agency costs to maintain slopes and provide mobility. In this study, the unstable slopes of interest are those that affect the roadway and include landslides, rockfalls, unstable soil embankments, and debris flows. These events block traffic, increase maintenance and safety risk, and siphon funds from operational budgets. Delaying response often allows the problem to become worse, increase risk, increase the frequency of damage, cause inconvenient road closures, and increase costs to the agency through higher maintenance and mitigation costs. This program has been led by Western Federal Lands Highway Division through two phases. Phase 1 was managed by the Alaska Department of Transportation, and then through the Western Transportation Institute at Montana State University for Phase 2. My company, Landslide Technology, has been involved with both phases with the assistance from Paul Thompson with benefit cost approaches and D.A. Stanley Consulting with performance measures. My name is Darren Beckstrand, and I'll be with you for the next few modules. Most transportation agencies have generally reacted to geotechnical problems as they arose, whether the issue is a landslide, a failed embankment, or road closures due to rockfall events. Recently, however, there has been a move towards applying asset management principles and processes to geotechnical assets. There is a greater appreciation for the roles that these dirt assets play in transportation systems, and geotechnical asset management, or GAM, is increasingly recognized as an integral part of transportation asset management. The USMP gives your agency the tools needed to locate, inventory, assess, and prioritize unstable slope assets to meet performance goals, shifting from a reactionary, high-cost method of managing slope assets to one where systematic improvements are made in a preventative and proactive manner. This is the primary driver for the federal guidelines requiring asset management for select asset types. As geotechnical assets deteriorate during their life cycle, most transportation agencies resort to a short-term, worst-first approach in determining when or whether to ignore, repair, rehabilitate, or replace the asset. For example, rockfall inventory programs in many states rank rockfall sites so that the most dangerous slopes receive first attention. However, expending limited funds on worst-first short-term problem fixes can result in steadily declining conditions for transportation systems. The USMP includes rating criteria for rock slopes and unstable soil slopes, focused on roads and trails managed by the FLMAs. It also includes database tools for rating data storage, performance measures for slopes, and benefit cost calculations for planning and decision support. This video focuses on rating rock and soil slopes. By now you should have a copy of the rating form in front of you. Once filled out, this two-sided form will contain all the data needed for locating and evaluating each unstable slope. The form includes a portion for critical location information and site measurements, and preliminary rating criteria with categories specific to either rock slopes or landslides. The second page contains spaces for rating categories relative to the slope's hazards, the risk it poses, and the site's total score. Category descriptions and evaluation guidelines for each criteria are contained in supporting documentation. Now let's get started. Planning for the field assessment starts with a call to maintenance personnel. Discuss roads to focus on with both your geotechnical supervisor and those maintenance personnel responsible for its upkeep. They will let you know the maintenance hotspots, relative rockfall and landslide activity levels, and where accidents may have occurred in the past. Review a topographic map of the area and discuss the unstable slope locations, and if possible, visit the sites to discuss site-specific issues prior to finalizing site ratings.
To start, we'll go through a checklist of items to get ready for field assessments. First and foremost, the most important aspects are your safety equipment. This includes a reflective vest and hard hats, and also traffic cones to place around the vehicle. After those are placed out and you have all your safety gear on, you can grab your other field gear, including a tape measure to measure various rock slopes and offsets, a laser rangefinder for larger distances, a calculator, a camera, preferably with the GPS monitoring system on there so you can geotag your photos and know where they're at, field notebook, a field form, the field manual to describe each one of the categories, and your selected device for entering field data. So the first thing you'll want to do when you drive up to a site is determine if it's a rock fall or if it's a landslide issue. The primary way you do that is you take a look at the site and you determine what's the major problem. Is it an accumulation of soil coming down, or is it a accumulation of rocks or individual rocks coming down? At this site you can see that there's a mix of soil and rock material, but the likely main problem here would be rocks coming down on the road. This site would be a rock fall site. This site is a landslide site. You can see the cracks in the road, the embankment dropping down, and this is pretty clearly a landslide site with another rockfall site right behind me. When there's a question and you're not sure, feel free to rate both of the criteria and see which one has a higher hazard rating. The field form is separated into 4 distinct categories: the site information, the preliminary rating, the slope hazard rating, and the risk rating. The first part of the form is what we're going to talk about first. And that's where you fill in the site information pertaining to your relevant site. One of the most important things to remember on here is to make sure that you're filling in your management area in a manner consistent with your agency's protocol. For instance, here at the Gifford-Pinchot National Forest, the Forest Service may opt to abbreviate that to GPNF. National Park Service may use their 4-letter acronyms for their national park sites, like YELL, Y-E-L-L for Yellowstone. Discuss with your managers which acronyms you should be using on your forms. So this is the beginning of the site information form. Here we discuss the management area using the correct 4-letter or the acronym that your agency decides on, the date of the rating, the road and trail number. These may vary in your agency. Check with your management personnel for a map of what trail numbers or road numbers you'll be using. And also a checkbox if it's a trail or a road that you're evaluating. Its classification. Here in the Forest Service, they use maintenance levels for their road classification. Your agencies may differ. The personnel evaluating the slope. The beginning mile marker and ending mile marker if your road system has it. Many roads do have that, but some do not. Check with management. The side of the road. Typically this counts up either left or right as you go up mile points. For instance, the slopes here, they're on the left of the road because the mile point markers are going up as we travel that direction. The weather. Here it's a nice sunny day here in southwest Washington. The hazard type, rockfall, then also some of the information that pertains to the rockfall. If it's a planar, wedge, or topple failure, or multiple failures through the site, you can circle more than one through here. Same thing with landslide, if it's above, below, or across the route. If it's translational slide, rotational debris flow, etc. You can leave those blank if you're unsure. The beginning coordinate, that would be the beginning of the site in the latitude and longitude, and also the ending coordinates in latitude and longitude. And the datum you're recording in. The default datum for this program is WGS 84. So average annual daily traffic, that's the number of vehicles traveling on the road on average over the entire year. The remainder of these categories factor into the ratings below, so I'll describe those in more detail. So the first category to evaluate in the site information is the length of the affected road or slide. This is done by starting at the beginning of the slope section and then ideally using a roller tape to walk the length of the feature. Deciding when to end a slope is an important judgment call. Here I decided to end the slope where the rock had changed from a exposed rock cut to a soil slope and to where it narrows down to almost no cut at all. Overall, this slope was 634 feet long. The next field to evaluate on the site information portion of the form is the slope height of the rock slope or the axial length of the slide. The best way to do this is with the laser rangefinder. After I set it to the vertical distance on the laser rangefinder, I can shoot the tallest part of the slope. Here, after adding my eye height, I get an overall height of 86 feet vertical. Axial length on a slide is a little bit more difficult to interpret. Here's some adjustments needed because I don't know exactly where this is toeing out at the base of the slope. Here I'm using a judgment call of about halfway down to where the slope steepness breaks off to be a little bit more gentle, down about that bush. Looking down here, the axial distance is about 45 feet. The next field to evaluate is the slope angle. For rock slopes, some of the newer rangefinders will give you a slope angle when you shoot the top and the bottom of the slope. If you don't have one of those, you can use a clinometer, either directly or indirectly estimating. If it's safe to do so, you can get underneath the slope and shoot up to try and approximate either the slope adjacent to you using the clinometer or shooting up the slope in this direction. But only do so if it's safe place to be. For landslides, I'll get the slope angle down the axial length of the slope by walking up and approximating about when I'm right on the plane of the slope. Here the slope angle is about 39 degrees. Sight distance is the next category on the form. It's the distance that a traveler has to see a hazard on the road and then react to the seen hazard. Once you see the hazard, you can start walking and measuring that distance. That distance that you're measuring is the decision sight distance for the slope. 217 feet. The next field on the form is the roadway width, or trail width if we're on a trail. Here the purpose is to determine the width of the road available to avoid a roadside hazard. A narrower road will be more hazardous, while a wider road will be less so. If there's a paved shoulder for a portion of the slope, you use the minimum distance of the roadway and ignore the paved turnout or shoulder. Here I stop at the edge of pavement, 26 feet. The next category is speed limit. That factors into the AASHTO decision sight distance that is required for a site and also the average vehicle risk. Record the speed limit for your site as you drive up to it. For the block size or volume category, you look at the rocks in the ditch and measure the maximum dimension of the block sizes present. If there are no rocks in the ditch, use your judgment on what's a reasonable large rock size from the slope. Here this is 5 feet, and it looks like it's even bigger here across the top. The category maxes out at about 4.5 feet. If it's a volume estimate, you can look at the different size of the rocks and the quantity of rocks in the slope. Here they both would max out because the rocks are large and also a large volume of rocks came down at once. I marked down both. The next field is annual rainfall. Here take a look at the available rainfall data for your region and be sure that you are taking into account the effects of the mountainous terrain on your rainfall. At the bottom of the slope, it could often be much lower than it is higher up in the mountains. So after completing the site information portion of the form, filling in other items not completely discussed, such as ditch width, ditch depth, slope, and any comments you have on the site, including if it's a sole access route, if there are mitigation measures present, and the number of photos and the range of the photos that you took while you're on the site, any comments you may have. The next portion of the form is the preliminary rating. Note that these are subdivided into 4 different categories with a 3 to the power of x type of scoring sum, a 3 to the power 1 of 3, 3 to the power 2 of 9, 27, 81, and so forth, with the knowledge that these have maximum scores of 100 points each. Note that some of them are for landslides only, some for rockfall only, and some for all slopes. After you evaluate all of these, look at the preliminary rating, and if the sum of them are between 15 and 21, it's a good slope. In 22 to 161 points, fair and poor are slopes that have a score of over 161 points. Check with your management personnel, but at this point, sites that are rated fair or poor receive detailed evaluation either now or later, depending on what your agency decides. The first category in the preliminary rating is for Category A, landslide roadway width affected. This is where we evaluate the width of the road that's being impacted or affected by the landslide. Here you can see that we're within the first category, the 0 to 5% of the road width being affected. But further up the road, we get it a full 25% of the road, and that maximum distance is what is being rated in this category. Other slopes may easily be up to 100% of the roadway width being affected by the slide. The next category is Category B, landslide, slide or erosion effects. This is intended to measure the effects of the landslide on the roadway, either through a dropping down of the roadway like we have here, or deposition on top if you have a slide above the roadway. We talk about anything from a visible crack, like over here, or something that's more offset right here. We measure the worst part of it on the slope. Here we measure the maximum displacement on the slope on this slide as approximately 4 inches, which is 81 points. The next category is Category C, road length affected by the landslide. We start off with where it's beginning to affect the pavement all the way to the end. This is one of the calculated scores, and so you take the measurement, enter it directly, and the score will calculate out. (130 feet). Category D, rockfall, ditch effectiveness is the first rockfall category. This is separated into good, moderate, limited, and no catchment, and usually is a result of the judgment of the rater. A good ditch will catch nearly all the rockfall coming down on the site, typically in the 90%. A moderate ditch effectiveness is reduced from that, while limited, more of the rocks will reach the roadway, while a no catchment category, almost all the rocks would reach the roadway. One of the items to consider is the presence of launch features on the slope. Here, a fresher rock ledge is present on the slope that would kick rocks out falling above and reaching the roadway, reducing the effectiveness of the ditch. Other aspects to consider are the presence of debris fans, where soil debris has filled the ditch and reducing its effectiveness. The minimum ditch effectiveness for a site is what you'd evaluate for this category. Here, I would rate it as moderate. You can also note how many rocks have stayed in the ditch in this location, with only a few scars in the road here, showing that the ditch is typically good enough for the rock fall that is occurring. The next category is Category E, the rockfall history. Ideally, you'd want to talk with maintenance on what the rockfall history of this site is. If they are unavailable or otherwise occupied, you can also take a look at the appearance of the slope ditch. You can see here that there's not been a lot of ditch cleaning that's been done. The weeds are high, indicating that there's not been a frequent clean out, and also a lack of equipment marks in the ditch indicates that the rockfall here isn't too active. Here, judging based on in the absence of maintenance information, judging on the quantity of material in the ditch still, probably accumulated over a number of years, I would estimate this to be occasional rockfall, 9 points. The next category is Category F, the rockfall block size or volume per event. As we mentioned earlier, we had a 1, 2, 3, or 4 foot size for the categories, the 3, 9, 27, or 81 categories, or a volumetric event. Here we had estimated 7 feet or 30 cubic yards, which both max out the score, at 100 points. Category G is the first preliminary rating category that applies to both landslides and rockfalls. This is intended to measure or approximate the impact on traffic should a probable event occur at the site. It should take into account the history of the site, the availability of a detour, and also maintenance inputs. At this site here, I would estimate that based on the rockfalls in the past, that it would be rated as a partial use remains, use modification required, and a short 30-minute detour may be available.
Okay.
Category H on the preliminary rating also applies to both landslide and rockfall sites. This category is designed to capture route or trail importance and can be assessed using either quantitative or qualitative data. The ADT of a roadway gives a rough quantitative indicator of its impact on the regional economy and mobility of people, goods, and services. So when that's available, use that. For those roads or trails where traffic volumes are not available, a qualitative scoring relating to its usage and relative economic and recreational importance can be applied. For sites where both qualitative and quantitative data is available, both categories should be evaluated with the highest resulting score given to the site. For example, a roadway that is the only route to a popular trail may be of moderate recreational importance, or 27 points, but the ADT may only be 200, or 9 points. For this site, the higher score of 27 would be used. After completing the preliminary rating for your landslide or rockfall site, you take a look at the bottom of the preliminary rating table. For a landslide site, you'd only add up categories A, B, C, G, and H, A, B, C, G, and H, or D, E, F, G, and H for rockfalls. Looking at our two sites over here, we had either 120 points for the landslide that we were evaluating, or 136 points for the rockfall we're evaluating. Both fair sites. Since these are both fair, then if management requires it, then we turn over the sheet and begin our detailed rating.